Hello everybody, welcome. This is paper 1 from May 2022 and this is time zone 1. So I think this is actually quite a challenging paper. 4-mark question, let's have a look. A vertical pole stands on horizontal ground. The bottom of the pole is taken as the origin O of a coordinate system in which the top F of the pole has coordinates 0, 0, 5.8. All units are in meters. The pole is held in place by ropes attached at F, so F is the tip of this pole. One of the ropes is attached to the ground at point A with coordinates 3.2, 4.5, and 0. The rope forms a straight line from A to F, so from A to F right here. Okay, so what's going on here is we've got a three-dimensional grid where this corresponds to X, this corresponds to Y, and then this is our height. So here we're saying we're 5.8 meters above the ground. This is kind of a rare question. Don't often deal with three dimensions, but we do, of course, it's on the syllabus. So let's draw a diagram and see what is going on. Actually, we'll draw a diagram a little later. Let's look through this first question. Part A asks us to find the length of the rope connecting A to F. So we want to find this length right here from A to F. 2-mark question. This question actually isn't too bad. We're given 3 dimensions, which makes it a little more challenging, but if we look to the formula booklet, we actually do have a formula for this. So let's go ahead and look at the geometry section of the formula booklet. So here we are, geometry and trigonometry, and distance between 2 points. Distance between 2 points when we have 3 dimensions, when we have X, Y, and Z. Okay, so here it is. Distance between X1 and X2, square that. Y1, Y2, and square that. And then Z1, Z2, square that. So for this question, let's make sure to label each of the coordinates, and then we'll just use this formula. Okay. So here is our distance formula. I'll write it in. Distance is equal to the square root of, we have x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1. Not a bad idea to actually label these coordinates. It doesn't matter what we choose to be x1, y1, z1. As long as we're consistent, it should be okay. Let's choose this just because we'll avoid some negatives, at least in part. We'll get to avoid more negatives. x1, y1, z1, and let's call this x2, y2, and z2. Okay. So here's our distance once again. I want to take the square root of all of this business, and we'll have, oops, I guess I didn't avoid negatives in the end. But since we're squaring all these values, the negatives will go away. And we have 0 minus 4.5 squared plus, and now here we have 5.8 minus 0 squared. Okay, and that should give us our distance. So let's go into the calculator screen and work this out. So let's take the square root of, and the 0 minus 3.2, I'm going to write this out just exactly as it is, but essentially if we're squaring, we don't need the 0, and even this negative, since we take a negative and then we square it, it just turns into a positive. This would be equivalent to 3.2 squared, but let's write it out exactly as it is. Plus Z2, this would be 5.8 minus 0. And we want to square that value. Okay, 0 minus 3.2, 0 minus 4.5, and 5.8 minus 0 squared. Okay. In this case, we have 8.008. Let's write this out. Going back to the document here. Distance itself would be equal to 8.008 8.08 or 8.01, and this is again in meters. All right. Part B asks us to find FAO. So angle FAO, the angle the rope makes with the ground. So FAO, remember we start at F, go to A, and then go to O. All right, so this is a 2-mark question. How can we solve this? There's somewhat tricky. I mean, we might say, okay, this is a right angle, and it really is. But since we're dealing with 3 dimensions, I'm actually going to draw a quick coordinate grid. And I hope this isn't, make it more confusing. But our 3-dimensional coordinate grid, if this is our Z, so our height, we also have an X dimension, or we can call this Y. Then we have this dimension right here. So we're dealing with 3 dimensions on this question essentially. And this would be Y. So our XY grid that we normally have is now laid flat, and we have this Z dimension kind of just going right through it, right through the center. And we have this rope. Here's the tip of our flagpole, and it's going down to some point A. So if this is F, for example, and this is A, we've got this flagpole, and the flagpole itself would be around this point right here, so along this edge. And the question is, if we wanted to, let's say, imagine that this is a right angle triangle, and we might say, okay, well, just a right angle triangle question, let's use sine, cos, tan. We know that this is 8.01, and then we have another side length. And you might be wondering, okay, is it 3.2, is it 4.5? I guess the danger would be to say that this is 5.8, which it is, and then the question would be, okay, can we use 3.2? Or can we use 4.5? But it's really neither of these. For this question, what do we know for certain? We know the length from F to A is equal to 8.01. This is equal to 8.01. And we also know the height of this flagpole on 3 dimensions is 5.8. So we know that this right here is equal to 5.8. And now in that case, if we want to find FAO, so this angle right here, FAO, now we can use our right angle trigonometry. So let's go ahead and do that. I'm going to grab this, bring it over here, I'll leave it here, it's fine. So what do we have? If we want to find this angle right here, we have the opposite and we have the hypotenuse. So remembering SOHCAHTOA, we have the opposite and the hypotenuse. So we should use sine theta. Okay. So I'll try to fit it in here if I can. Sine theta is equal to opposite over hypotenuse. And in this case, sine theta is equal to opposite is 5.8, and the hypotenuse is 8.01. After that, you can go ahead and end solve. And I apologize for the lack of space or how condensed it is. But we can write this as also theta is sine inverse 5.8 over 8.01. Either of those should work. You can either end solve this original equation, or we can take the inverse, whichever you're comfortable with. Just make sure you are in degrees, of course. So 5.8 divided by 8.01, and this is going to give us a value of 46.39 or 46.4 degrees. Okay, so once again, distance formula for 3 dimensions given to us in the formula booklet, and then given that we have a right angle triangle, we know this absolutely, and we know one other side, and that's because we know that our pole is centered at this point 0, 0, 0, and it just goes up 5.8. So we know this length, we know this length, and then we can write a right angle triangle and then use our SOHCAHTOA or our trig functions to solve. Alright everybody, I hope that was helpful, and as always, best of luck. Take care.